Hey there, I'm Joe Carter. If you've ever popped the hood and thought, where do I even start? You're in good company. Around here, we take the mystery out of car repair, one fix at a time. Whether you're a beginner or just looking to sharpen your skills, there's something here for you. Don't forget to like the video and subscribe if you're into learning without the headaches. All right, that's enough from me. Let's get into
Low oil
it.
pressure sensor. More meters of this type are called sensors on the lamp, since in the case of a drop in pressure in the lubrication system, a control lamp lights up on the dashboard. Additionally, a buzzer can be connected. On some systems the design assumes two sensors. According to their internal structure and principle of operation, pressure meters are divided into the following types: contact type, rheostat type, pulse type, piezo-crystalline. Let's consider the divisive membrane sensors of contact, rheostatic and pulse types. It is they that are most often used in the lubrication system of modern cars. Sensor on the lamp. The device of the sensor of the contact type, on the lamp, movable contact, rod of the movable contact, pusher. Diaphragm, housing, fixed contact, signal lamp, P, actual pressure in the lubrication system. POR, critical level, at which the indicator lamp lights up. UBS, voltage of onboard network. One of the contacts of the signal lamp is energized from the onboard network after the ignition is switched on. The second contact is connected to the movable contact element of the meter. The principle of operation of the signaling device is based on shorting the second terminal of the signal lamp to ground. A movable contact is responsible for closing and opening, which is connected to the diaphragm via a pusher. The over-diaphragm cavity of the sensor is connected to the engine lubrication system through a channel, shown by a red arrow. As the lubrication pressure in the system increases, the force on the diaphragm increases. This causes the diaphragm to bend, moving the movable contact away from the stationary contact. Figure A shows a situation in which there is no pressure in the system, the contacts are closed, and the light is on. In Fig. B, the actual P is greater than the calculated critical level POR, so the circuit is open and the light on the instrument panel is not illuminated. Absolute pressure sensors. Absolute pressure gauges in the oil system can be rheostatic or pulse type. Figure B shows a diaphragm sensor of the rheostat type. As with the contact gauge, the actual oil head is transmitted by the deformation of the diaphragm. The degree of bending of the diaphragm is transmitted through the rocker to the slider, which moves along the resistive layer. The electrical part is a conventional rheostat. The resistance in the circuit depends on the position of the slider and thus on the degree of diaphragm deformation. An analog pointer on the dashboard can, on the same principle as the fuel level gauge, or be built on the basis of a bimetallic plate. Pulse type gauge. Figure B shows a pulse type diaphragm gauge. The device of the pulse meter assumes the presence of a thermobimetallic vibrator inside the sensor. Fig. B number 6 shows a thermobimetal with a spiral and a movable contact. The transducer includes an upper and a lower contact. The upper element is a plate with a helix wound on it. The lower one is connected to the diaphragm and is shorted to ground. When cold, the bimetallic plate is straightened and closed with the lower contact. Current flows in the circuit, which heats up the spiral inside the indicator on the dashboard. The heat from the coil is transferred to the plate that is connected to the analog pointer arrow. The heat causes the plate to bend, moving the pointer. But since the oil pressure sensor has a similar bimetallic plate, it also deforms when heated, disconnecting from the bottom contact, and thus interrupting the flow of current in the circuit. When it cools down, the plate returns to its original position and the circuit is closed again. Malfunctions. Residual deformation of the bimetallic plates, which subsequently leads to incorrect readings. Failure of the bimetallic plate heating element. Device of the lubrication system of the car. Oil pressure sensor design. What oil pressure sensors are available? In conclusion, understanding the principle of operation of the oil pressure sensor is essential for maintaining optimal engine performance. This crucial component continuously monitors the pressure within the lubrication system, ensuring that the engine receives adequate Oil flow for proper functioning. By detecting any fluctuations in pressure, the oil pressure sensor helps prevent potential damage and extends the life of the engine. Regular checks and maintenance of this sensor can lead to improved reliability and efficiency, ultimately contributing to a smoother driving experience. Thank you for watching, and stay tuned for more insights into automotive technology.